All right, so for this one, with the applications of quadratics, it says the height of a ball t seconds after it is thrown is modeled by this particular function. That was a one, where h is the height of the ball in meters and t represents the time in seconds. It asks you to find the maximum height reached by the ball. Now, this maximum height, what did that signify? Maximum height. What part of the vertex? The y. Okay, because think about it. This is a quadratic, guys, that points down because the quadratic term is negative. So because it points down, when it asks you for the maximum height, you're basically looking for the y coordinate of the vertex. Okay? Now the x coordinate will basically tell you the time it took to reach the maximum height, but the y coordinate actually gives you what the maximum height is. Okay? So how do we find this value? You have to do negative b over 2a. Oops, I have backwards. 24 over 4.9. Okay? Is it 58.8? Was that the end of it or did it keep going?
Great, I'm not sure. I'm gonna borrow your calculator.
Yeah, I want everybody to have their calculator out. So then that way we can double check all this.
Yeah.
So we're doing negative 24 divided by 2 times the negative 4.9. And make sure if you're doing this all in one line, you're putting that entire denominator in parentheses. So we're looking for the y value of the vertex. It was just that?
Yeah, it's just
58.8? Okay. So then to find the y coordinate, what do you have to do? Plug it back into the equation.
I stopped there. I was like, this is it. Or like, you know, the drawing of fire.
What'd you guys get? Y'all did not get 58.8?
I got 58.
Oh, okay, so this is what happened with that as well, because me and Lexi, she did it that way, she got 2.4 something, because she did the bottom first and then the top and divided it separately. So I plugged it into calculator and did it all in one line. So got different answers.
Yeah, because this right here, if you did this, what the calculator is reading right now is do negative 24 divided by 2, which is negative 12. And then they're saying basically take negative 12 and multiply by negative 4.9. That's not what you want the calculator to do, but that's what the calculator is reading. It does order of operations. Like it does. So in order to make sure the calculator knows that, hey, I want negative 24 divided by, what is that, negative 9.8, whatever that is when you multiply 2 and negative 4.9, you have to put in parentheses, or else the calculator is going to go based off of order operations. So it's actually that number. That is actually the x coordinate of a vertex. And plus, 58.8 means it would have almost taken a minute for the ball to reach its maximum height. Does that make sense?
No wonder I was going to go through your answers for the second one. This does not work.
Right. So, in order to find the y coordinate, we basically have to take that answer and plug it in. But remember, anytime you have to use an answer to, like, further after that, use this long decimal. It's already in your calculator, okay? You basically have to take 24 and multiply it by that long decimal. So if you do second negative, and go ahead and plug it in. Minus 4.9 times that long decimal again squared plus 1. And by doing this, once you get your answer, you can round that and you'll be more exact. So your maximum height is what? My maximum height is my maximum height is 30. It's asking for what length of time will the ball be higher than 20 meters? For what length of time will the ball be higher than 20 meters? So you have this quadratic that represents time in relationship to height. At some point in time, the ball is going to be higher than 20 meters. You have to find this length of time, which means you're looking for what value? You're looking technically x represents your time, y represents your height. You already know your height has to be 20. You're looking for your time, which means you're looking for your x values when y is 20. Okay? So you basically have 20 equals 24t, or x, minus 4.9 x squared or t squared plus 1. You're looking for your time. You have to solve for time. How would you solve for time? How would you find that value? You can use quadratic formula. Okay? In order to use quadratic formula, I have to get everything to one side, correct? So I have 0 equals, and just for the sake of A, B, and C, I'm going to rewrite it. So now we use quadratic formula to find time. I want you guys to do that right now. I want you guys to use quadratic formula and find the time the ball is higher than 20 meters. You're going to have 2 solutions, as you can see. You have to figure out what those 2 values are. What? Did you guys get these values as well? Okay, so those are your 2 values for t. Solving using quadratic formula. You know, negative b plus or minus square root of b squared minus 4ac. Now it says, for what length of time will the ball be higher? Well, it's higher than 20 meters at almost 1 second, and then almost at 4 seconds it drops below 20 meters. So, how do you find that length of time? Subtract them. So 3.90 minus 0.993. I'm almost certain these are rounded answers, so you know, be cautious about that. And what's that distance? What's that length of time? Is what? 2.91 seconds. That's the length of time. Okay? Questions? Alright. So again, guys, they ask you for a maximum height, minimum area, maximum, minimum, anything. What's it talking about? Vertex. What part of the vertex? The y value. Okay? Depending on the problem. So like in this case, the x value of the vertex would tell us how long it would have took for us to reach the maximum height. Okay, and if we're looking for a length of time, anytime we're looking for one of the variables, that's what we're solving for. Length of time, we're looking for x, technically. The ball is higher than 20 meters, 20 represents the y. We had to basically solve for t, which means we had to solve the quadratic equation. Now for this one, it says it takes Louisa 3 hours to ride her bicycle up the hill and back down. Her average speed riding down the hill is 35 kilometers per hour, faster than her average speed riding up the hill. So she's going faster going down than she is going up. And it says the distance from the bottom of the hill to the top is 40 kilometers. Find Louisa's average uphill and downhill speeds. It was a calculator, and I gave you a hint here on how to go about doing this. So I gave you guys this hint right here. Distance equals rate times time. You needed this because in order to set up your equation to figure out her uphill and downhill speeds, you needed this. Which part of this equation represents speed? R, the rate. Rate and speed, same thing. So R was your speed. You already knew what your distance was. What's your distance? 40. And T is your what? T is your time, but realize, guys, it takes 3 hours to ride her bicycle up and back down. If 3 represented T, then guys, 40 would be our distance. It would technically be 8, okay? But since we have to figure out her uphill and her downhill speed, we pretty much need to look at it separately. We can't look at it all together. Because we know one thing. Her rate is found by taking her distance divided by her time. Would you guys agree? Now, in order to travel 40 meters uphill, correct? From the bottom to the top, it's 40 meters. How long did that take her? here represents uphill, her uphill rate. Now, when she goes downhill, how far is she going? What's that distance to go from the top of the hill to the bottom of the hill? What is it? It's still 40. It doesn't change. It's not like the hill automatically shrunk or anything like that. No, it's still 40. What's her time it took her to get back downhill? X plus 35. Because we know she's going 35 miles per hour, or kilometers per hour faster than she was when she went uphill. So this right here represents her downhill speed. Now overall, if she goes 40 over x to go uphill and 40 over x plus 35 to go downhill, how long did that take her? 3 hours. So total, it would take 3 hours. What does x represent? What does x represent again? Her rate, her speed. And since we're looking for her uphill and downhill speeds, we basically need to solve for x in this equation. We didn't have the equation for this one. We needed to create one. And the only way to create it was knowing that distance equals our rate times our time. Okay? So, we're solving for x. Solve for x. You got 3 minutes. What do you guys get for your 2 solutions? 17.8 and all right, so of course you're going to get 2 solutions, okay? This is the quadratic here. I mean, you could have got one as a double root, but you got 2 solutions here. But only one of them makes sense, which is 17.8. So it took her 17.8 kilometers to ride which way? Uphill. Okay? That negative 26.2, you can't have that. Alright? That means something completely different than going uphill. Okay? So 17.8 kilometers per hour is the time it took her to go uphill. What about downhill? You have to add 35 to it. So when you add 35, what's your other time? So 52.8 kilometers per hour is her downhill speed. So these are our 2 answers for this particular problem. Questions on this? This one was a non-calculated problem. It said the sum of the squares of 3 consecutive positive odd integers is 251. Find the integers. Now, this one should be familiar as to the problem of the day one. Okay, when we first started quadratics and I realized that we were getting behind, the one from the problem of the day said 3 numbers, 3 consecutive numbers. What do we use to represent 3 consecutive numbers? Just regular. X plus what? X plus 1 and then x plus 2. But if I'm talking about 3 consecutive positive odd integers, how would you represent that?
At this time, letters E through G, please go to the auditorium for pictures.
So, this right here represents 3 consecutive odd integers. Because if x was 3, then 3 plus 2 is 5, 3 plus 4 is 7. That's 3 consecutive odd integers. It said the sum of the squares. What does that mean? squaring them, you have to what? Add them. The sum of the squares of three consecutive positive odd integers is 251. This should have been the equation that you set up to solve for this one. Okay? Now, I do notice, now when you're solving this, guys, we're talking about three consecutive positive integers. Integers are what types of numbers? Types of numbers are integers. Say again. They're whole numbers, which means that in order for them to be whole numbers, that this had to be fractional. This was fractional, because if you get a whole number, you get whole numbers as well as fractions, but whole numbers specifically means you can definitely fraction this. Okay? Combining your like terms, you would have 3x squared plus 12x, subtract the 251 over, and you would have had a minus 230. Okay? 3 was factorable out of all of these. 231 divided by 3. Okay? 7. It was 77. And having done this, you would have been able to recognize that, oh, two numbers that multiply to give you a negative 77 that add to give you 4 are 11 and negative 7, making this a lot easier than trying to do quadratic formula and trying to take the square root of a big number when you know how to calculate. So x would equal negative 11 or x would equal 7. But, which one's right? 7, because we're looking for positive integers. So my three numbers are 7, 9, and 11. This one, a wire. Okay? Flip your paper over. Yeah, she's like, To be able to answer this question, you definitely have to know what part A is. So if the side length of one of the squares is x centimeters, what's the side length of the other square? What is it? It would be 10 minus x. So technically you were headed there. Because think about it, guys. First off, it cut into two pieces. And these two pieces are formed into two squares. They're not two equal squares. They never say anything about them being equal. It was two squares. Okay? Now, one of the squares had a length of x, which means that all of its side lengths are x. Okay? So then the other square would have to be out of the pieces of y that you have to cut. Okay? In order for this to be the square, what would the maximum side length have to be? Think about it. Square. All these sides have to be the same. What's the longest one side could be if you have 40 centimeters of wire? 10. Okay? So the longest that any side of either of these squares could be is 10. Okay? So if you already know that one square side length is x, the other one would have to be 10 minus x. Okay? Questions on that? That's your answer to part A. Because in order to show that the combined area of the two squares is that equation, what's the area of the square? How do you find the area of the square? Length times width. So you have x times x, and then over here, you would have 10x, or 10 minus x, times 10 minus x, and it said the combined area, which means you have to do what to these two? Then you would FOIL, this is x squared, this is 100 minus 20x plus x squared. You combine like terms and you get 2x minus 20x plus 100. But the one thing, in order to start this off, you needed to know that that side length was 10 minus x. Think about it. We did a problem today with the, no, not even a problem today, the very first example we did of applications. It's talking about a square that had fencing. Okay, it was the same type of setup. All right, except this time you had two squares and you basically taken away the amount of wire you have from one square to make the other square, instead of a length to make a width. And of course, to find the minimum combined area, what does that mean? To find the minimum, no, not 0 for y. The vertex, what part of the vertex? The y. And it said the combined area, so what equation are you taking? This one. Combined area, combined area. You have to find the y coordinate of this vertex. What is it? Say again. 50. Well, if it's not 50, what did you guys get? You got 50?
Yes, sir.
I'm about to say, get a show. When you do negative b over 2a, negative b over 2a, that would be what? What number would that be? It would be 5. Okay, so that right there would basically tell you what the length would have to be of these squares. Okay? So actually, obviously, they were equal. So then you would plug it in, you would have 2 times 25 minus 20 times 5 plus 100. That's 50 minus 100 plus 100. Those cancel out. So yes, it would be 50 what? 50 what? Alright? A lot of these problems, you'll realize the more and more you do, it's either going to be a variation of this one, just like how the very first one was talking about a farmer trying to create a perimeter. You have a wire, you're trying to form a square, same concept, they're very similar. You're going to have several ball type of questions. They can only ask you for so much. How long did it take the ball? How long was the ball in the air? What's the maximum height of the ball? What was, like, that's, I mean, those are the most, when does the ball hit the ground? Those are the 3 of the only type of questions you get asked about those. You'll start to realize that all these are going to start forming patterns. Yes, the one like Louisa and her riding bike, that is a unique one, okay? But realize that that's going to be like the most of those types of problems. We have to take 2 equations, combine them, set equal. Some of the squares, I don't know how much different you can get from those, okay? But they're all very similar to each other. Here's another one of those special cases, the golden rectangle. It has a property that if it is divided into a square and a smaller rectangle, the smaller rectangle will be similar in proportion to the original rectangle. Now, they're not going to give you this piece of information and you not have to use it to answer this question, okay? In the golden rectangle ABCD, PQ divides it into a square and a rectangle as shown. Given that AD is 1, you have to find AB. That's what you don't know, is AB. Now, in order to solve this, okay, you clearly need an equation that we don't have, but we can create it. What piece of information in this problem tells us how to create this equation? Because it's in that red writing up there. Say again.
Since A to B is 1,
Mm-hmm.
P would be 1 since they're
Mm-hmm.
and so A to B would be X minus 1. Well, P to B would be X minus 1. Sorry, A to B is X minus 1.
Okay. Not quite. Well, I guess you could say that. All right. But I still need an equation. There's something in here. I'll read it again. It has the property that if it is divided into a square and a smaller rectangle, the smaller rectangle will be similar in proportion to the original rectangle. Huh? Similar proportions. You remember, think back to geometry. When you did a whole unit on similarity. Similarity basically meant proportion. It even says proportion. What is a proportion? fractions that are equal to each other. You cross multiply to solve them. So think about it, guys. You have a proportion here. This right here is your equation that you're going to set up, and when you actually cross multiply, you're going to end up with a quadratic. Okay? Now the thing is, you got to make sure you set up the right proportion. Now it said that the smaller rectangle is similar to the original rectangle. You have to keep that in mind. The smaller one is in proportion to the larger rectangle. Think back to geometry and proportions, okay? If I'm trying to compare the smaller rectangle to the larger one, okay? How can I set that proportion? Don't plug in any numbers or symbols yet. Do the letters. Tell me. So BC. The longer side of the rectangle, which is AB of the larger one, matches with the larger length of the smaller rectangle. So AB goes with BC. And then, okay, one of the smaller sides of the smaller rectangle, like PB, would compare to one of the smaller sides of the larger rectangle, such as AB or BC. Now you already know what BC is, don't you? What's BC? 1. Oh, guys, sorry, guys. I had this backwards. I'm sorry. Oh, that's what you meant?
Yeah.
Then why don't you clarify that, then?
I was writing it down and didn't realize.
Sorry. I had it backwards. And I was going to write this just for clarification. This is the larger,
H through K to the auditorium for pictures, please.
and this is the smaller. So AB is the longer side of the larger, and BC is the longer side of the smaller rectangle. BC is the shorter side of the larger rectangle, and PB is the shorter side of the smaller rectangle. So you want to make sure that you definitely match up the proportions, or when you plug in, things are going to be a little awkward. So you already know that BC is 1. AB, let's take a look back over here how we labeled this. Do you want to leave AB as x minus 1? And if we do that, what's PB? If we leave it like that. Okay? If PB is x, then you might want to reevaluate this. X plus 1. So you have x plus 1, this one is x, and there you have your proportion that you cross multiply to solve.